Okay, so it seems that we are up, which is great. Just gonna say hi to everyone. Can I hear myself? One moment. Okay, yeah, we are up. Great, small delay, but hi everyone. Enter. This week, is my board plugged in? Nope, gotta plug in the board first. But once this is plugged in, I should also be able to doodle. And we are going to be talking about this, I think, relatively new tool called Nixtla. It's been like a thing for a while. I've seen it sort of like I've seen PyData talks about it. I think if you watch YouTube, you can also see some things about it. But the main thing that drew my attention, as you know, usually these things kind of go, is you go to a conference and you talk to someone you know, and they tell you, "Hey, I spent some time working on Nixtla for my time series project. It was kind of neat." So I've always kept Nixtla kind of in the back of my mind, like, "Hey, that might be fun for a live stream," because I met someone at PyData that was, definitely positive about it. But as it turned out, I couldn't really talk about it last week because it uses a hyperparameter optimization framework under the hood that I wanted to discuss first. So Optuna was a thing we discussed last week. But all of that is basically just a setup for what we're going to talk about today, which is this Nixtla stack. And kind of a way to think about it is they've got this new thing called TimeGPT, which is like a super big pre-trained model that's behind an API that you can kind of play with. But besides that, they also have an open source ecosystem, and it's a pretty interesting one. So they have separate packages that you actually have to pip install. There's one with pretty classical statistics-based forecasting methods. There's another one that uses more machine learning models, and scikit-learn integrates with this one quite nicely. So that's the one we're going to spend most time on today. There's also a set of features for doing stuff with neural networks. There's also a set of features for doing more hierarchical predictions. So you can imagine I'm a store and I am selling, I don't know, different types of cheese. And so that's a category. And under the category of cheese, you've got lots of different cheeses that you might sell. And you want to maybe predict the price or the demand for all of these. And, that's the hierarchical domain. There's also some feature engineering tricks, a separate library for that. But the thing that's kind of nice and interesting about just this stack in general is that although these tools are separate tools, they do remind, like if you've used ML forecast, the jump to stats forecast is actually not big. They are separate packages and you can't just swap out everything. But what is interesting here is that Nixtla doesn't just provide a package, they try to provide an ecosystem of tools, so to say. And that's relatively unique. Like sometimes you see some time series packages going for one of these. The fact that they're trying to support all of this stuff, I think, was definitely kind of a nice touch. So we are definitely going to dive into this ML forecast thing the most, and I prepared a bit of a notebook. The goal is to first sort of highlight what kind of Lego bricks they give you, and then we're going to dive into this data set that I think Ivan, he's probably listening, that Ivan gave me. Like he's a fan of the show, and he was kind enough to show me a data set with a time series on subway rides. So we're going to talk about all of that. But first, let's just talk about the moving parts from the Nixtla stack. So back inside of a Jupyter notebook over here, I'm definitely going to be talking about this ML forecast thing, but there is this utils submodule inside of ML forecast that I pip installed beforehand, and it allows you to generate just a data set that you can use for demos. So this is just plainly copied from the docs, and here's kind of a data frame that you would use. Now, there's a few interesting things about this data set, actually, right off the bat. So this is a pandas data frame. They're adding support for polars right now. But you can see that there's some sort of a unique ID. This is a must. You must have a column called unique ID. Then there's some sort of a timestamp. Then there's the thing that we are interested in predicting. And then you can add all sorts of other stuff that you would like to add, maybe for regression purposes, so to say. So maybe this is the temperature of this day, let's say. And maybe the temperature has a relationship with the thing that you're trying to predict. Could be price, could be demand, could be whatever. But one thing that's kind of cool about the stack here is that very often you're kind of in a situation where you're not just trying to predict one time series. Very often you're trying to predict many of them. Let's say one for every product, or one for every city, or one for every province, or whatnot. So what this stack actually kind of makes easy is it just allows you to say, well, there's just this column that we expect in a series data frame that's going to identify every single time series. And then you can still pass that one data frame to like a prediction object later, but you don't have to do a for loop around that. That's kind of the big thinking idea here. So if you've got lots of time series, you can still use one data frame and one prediction object, so to say. You must pass this though. This is mandatory. So if you're dealing with a situation where you're really just interested in one and only one time series, then you just put in whatever constant value you'd like over here, but you must pass this along. That's sort of an assumption that they do make on your behalf, so to say. But okay, this is a data set. It has lots of these unique columns, and what I can do is I can say, well, let's just plot let's just have a look at what that looks like. So I'm plotting the series over here. And so what I can do is I can have a look at the first ID, and then we can zoom out a bit, actually. So you can see here I've got like the first ID. I can put in like the second ID, and these are just very, very basic time series. There's like a daily thing, and there's like a bit of a seasonality happening here. If you squint your eyes, you can see that there's like a weekly pattern, right? There's like a spike on like one day of the week, and then it goes down again. There's a little bit of noise. This is obviously a synthetic data set, but it will serve for educational purposes, which is what I'll be doing. But the main thing that is good to observe is this is just a pandas data frame, so to say, and I'm able to zoom in on a specific ID, and then I can plot like, hey, what's the time, what's the value, and this is the thing that we're going to go ahead and try to predict. And we're going to have not just one of these, we're going to have many, because we have many of these unique IDs. So, okay, that's the data structure. Then let's get to the predictive bit. And this is where stuff kind of gets interesting too. So the thing with time series in general, right? Sometimes you want to add features that change the data set a bit. So let me try to draw that one out. So let me pretend that this is like my data set. I've got my dates time over here. Let's say that I've got my unique ID as well, right? And then I've got my y value over time. But then if I think about what kind of features might be useful for like a machine learning task, then one thing that I might be able to do is I might be able to say, well, maybe I want to have the previous day, or like the value from yesterday, so to say. Because if I know what value I had yesterday, maybe that will help me predict today. And you can kind of see that you might do that for like the day before that as well. So that's something you might want to do. But you kind of have to be careful here, because if you were to do this, right, and this is like the first date timestamp, and let's say I've got y1 over here, then we have the second one and the third one. It goes a bit down, so we've got these y variables, right, over time. Then at time step 3, I can look back 2 time steps, and these are like properly filled in. But at time step 2, I can only look at the previous value, and I cannot look 2 time steps back because there would be a value missing. I can only look as far as the history goes. And the same would kind of happen over here. So right off the bat, right there, if you're going to be generating some of these features, you kind of need 2 steps, because if you were to do this in scikit-learn land, right, then basically adding columns in scikit-learn, that is fine, but you would kind of also need to be removing some rows, because you cannot have rows with missing values in scikit-learn. So effectively, if you want to generate these features, you're going to have to sort of resample your data set a bit as well. And kind of the feeling that I get from Nixtla, like the main thing that they provide with this ML forecast object, which is the main predictive object that they give you, is they try to give you a way to just put in a bunch of models, put in a bunch of these feature generation techniques, and then they will make sure that all of these steps that you got to do play nice with one another. So my impression, maybe, to put it that way, is that under the hood, you've got this ML forecast object. And then you've got your X and your Y, let's say, like, or actually, there's no Y here. You've got your, I think, let's call it just a data frame, because that's what it is. You've got your data frame. Then there is this pre-processing step that basically gives you a new data frame. But one thing that's really typical is this will typically have less rows than before. And that is because, of course, if you're doing something with lag values, then we got to delete some of the data in order for the data not to have missing values. And then we are going to pass it to a machine learning model. So it's kind of like a pre-processing phase, something that's happening. But after that, it does something extra too. So you can imagine everything that I'm showing here is kind of like standard scikit-learn stuff, right? Like I might be able to make a prediction. But let's say that I've got like 3 lags, so like I'm looking back 3 time steps. It might still be the case that I'm interested in making a prediction like 14 days forward. Like I might have a time horizon that I want to predict forward that's larger than the lags that I've got. So this machine learning model at some point is going to be time to make a forecast, right? I'm going to be making predictions forward. But what it's also going to do under the hood, it is going to apply this recursive trick where I'm able to look back, let's say 3 time steps. And if I need to make the prediction for the 4th time step, then I will actually start using a predicted value as a previous value at some point. Because you can kind of imagine if this is like the time series, this is like what is available. Right? Let's take it, every slot here is just a day. If I have a model that needs to look back 3 time steps, then at this point I might be able to predict y plus 1 because these 3 are properly available, so that's not going to be an issue. But if I want to maybe now predict y plus 2, well, then these 2 might still be available for my original available data, but in order to have a value for yesterday, I'm going to have to look back on a predicted value. And that is also something that Nixtla can sort of handle for you under the hood. It's not just this pre-processing. It is not just accepting machine learning models and doing hyperparameter tuning. It is also that when you're making a forecast, it can do this recursive thing. And if I think back of some of the time series stuff that I had to do before, it is just kind of nice. You don't have to write all this stuff manually. Like the fact that that's all kind of integrated and tested, I think that's the main feature of this ML forecast thing. It's just some stuff that you would definitely still be able to do yourself, but because it's a proper open source project, it should be like well maintained and it should be way less error prone to do this recursive kind of stuff and to do this data preparation kind of stuff. So there should be a little bit less data leakage, let's say, and also when you're making forward predictions, there should also be less like manual errors and stuff. So that's in a nutshell what this ML forecast object does under the hood for us. So that's actually kind of nice. And if you were to go to some of the other forecasting tools like stat forecast, let's say, my impression is that the preparation and the forecasting, that's all kind of the same. It's just that ML forecast is assuming that you're going to give it scikit-learn models, whereas stat forecast is sort of assuming you're going to get more statistical objects instead. And that's where these tools kind of differ. But in terms of, oh, it wraps around and handles stuff automatically for you, that is definitely something that the Nixtlaverse tries to standardize, so to say. So that's... I've not given it like the super biggest benchmark or anything like that, but I did appreciate at least that design decision. It did feel kind of clean. So that was kind of a pleasant little surprise. Now, before diving into the API, this would be an excellent point in time to ask questions. So if you have any, do let me know. But I hope that before moving forward, it's at least clear, like, hey, there's stuff happening under the hood for us. It's kind of a big object, especially when you consider, of course, that this is not just happening for one time series. It's doing this for all these different time series that you're passing along. But it's nice that stuff like this is being handled for you. So this is all very well and good. I don't see any questions come in, so that means that we can move on to the API. So how does the ML forecast thing work? Well, you're going to make this forecasting object, but you're going to have to tell the model a few things about the data frame that you're going to give it. For starters, you might have a list of models that you would like to run. So in my case, I'm just giving it a linear regression and a histogram gradient boosted regressor thing. These are just scikit-learn models. As long as they're regressors, they should go ahead and work. But the thing that's just kind of nice is you can pass more than one model in here, and it will also just loop over all of them. The next thing that you're typically going to want to pass is you're going to want to say, well, what's the frequency of my data frame? This is kind of important. Like this bit me when I first gave it a spin. So normally a lot of these time series models are on a daily basis. So you want to make a prediction every day. But you can imagine that lags and stuff and like how many days do I look back to generate features, that does depend on the time scale. So if you're interested in making a prediction every week, that's going to be different than if you're going to do that for every hour. So if you're doing hourly stuff, I think daily is default. I could be wrong on that, but if you see weird model predictions and you're doing hourly stuff, that's probably because you didn't set this flag, or at least that happened to me. After that, what you can do is you can give it some like features to go ahead and generate for your time series model. So, for example, I can say I want to have lag values that look 7 days back or 14 days back. So there's like a week, the week before, and like the 2 weeks before. Those are features that are going to go in. But then you're also going to be able to add these lag transforms, which are kind of interesting too. So lag is really just saying, hey, I'm predicting YT, and in order to predict YT, I'm looking back 7 days, and I'm looking back 14 days. So those are just simple lookbacks. But you might also have this expanding mean, for example, where kind of the whole point is that you're going to be looking at more of a rolling mean that just sort of keeps on growing. Um, like a rolling mean will have a window that moves over the time series, but an expanding mean will just keep on expanding, so to say. And I will say for like general, like it depends on the time series how much this is going to be useful. But I can say like if you're dealing something that's very trend heavy, so like there could be an upwards trend that lasts for 2 years and it could be going down after that again. Like for those kinds of situations, a rolling mean like this is actually just kind of useful. So if I understood this correctly, the way to read this is that this rolling mean has a window size of 28. So this is going to average, let's say, a full month of data points. But if YT is, let's say, over here, then it's going to look back at the rolling mean at YT minus 7 from like a week ago. So you're not going to be able to calculate the rolling mean up until right now, but you're going to be able to look back, let's say. And you can also go for like a shorter rolling mean, which is what is happening over here. This is 14 days. And the thinking here is that if there's like a more longer term trend, the model might be able to contrast that to a more shorter term trend. And those are features that you can go ahead and generate. So that's all the lag feature stuff, which is good. There's more features that you can add. Under the hood, there are like a couple of these strings, but you can also pass your own functions, if you will, that are just one-to-one mappers. So you can imagine, hey, I've got a date time object. Maybe I can get the hour of the day out, or maybe the day of the week. Maybe there's also like a flag for weekend, let's say. These are just stateless featureizer techniques on the date itself, and these can be super useful as well. So, you know, that's also kind of nice. That's also something that's been added. And then finally, a thing that is common depending on what you're doing is you can also add target transforms. So the thinking is that, let's say I want to predict the value YT, let's say, right? Like instead of predicting the exact value, what I could also do is I could just maybe calculate the difference at time t, which is the previous, which is the current time step minus the previous one, let's say. And it could very well be the case, for whatever reason, that this is just a little bit easier to predict. Like we're just going to try to predict the deltas instead. And the funny thing about that is, of course, that if you have the previous value and you know the delta that you're predicting, you can still get to this YT value. But there are these situations when maybe doing a target transform is just going to make your day easier, and that is something you can also totally do. And hopefully at this point you can kind of look at, oh, we've got these lags, we've got this dates transform, we've got these target transforms. Right, we do have to set the whole system up in a nice way, so to say, but once you're actually here, the ML forecast object will just handle all that pre-processing for you, keeping in mind all these different groups in your time series as well. So, in a way, you could look at that and you could kind of say, well, it gives me like a little bit less control, right? Because looking at this, what I got to do is I got to think ahead a bit more, and, you know, it's a bit more configgy in that sense. But maybe that's fine because it also provides you a bit of consistency. Like it doesn't expose all of the internals for you, but maybe that's also kind of okay because you get a lot of stability out. So, okay. This is the way you configure everything. Let's look at some of the results that it gives you. Now, one thing to just observe, right? I'm just going to zoom out one smidge here. This series object, that's the thing that I started out with. It has 1,400 rows or so, a little bit more. I've got my forecast object, and my forecast object can train machine learning models, but it can also pre-process the data. So I can give it this series object, and I can ask it to just go ahead and pre-process. And what I do, you can actually see that there is this lag 7 value, there is this lag 14 value, so it's definitely generating all the features that I'm interested in. You can also see that it's doing that for every single group, so that's also good. But you're also going to see that in doing so, you will have way less training data going out. And that makes sense. Like if I need like a month of training data for every single group in order to generate all of these features, if I don't want to see missing values, and yeah, you're gonna have about like 19 of these groups times 28 values. That's a chunk of data that you're missing. If I were, just for example, to remove the big rolling mean that I have over here, right? So that's the big 28 lag thing. Note that before I had 761 rows going out, and if I were now to rerun this, yeah, I have 1,000 rows going out now. So it's the bigger lag things. Those are the things that are gonna give you more information, but they're also gonna remove rows from your data set that you're gonna be able to train on. So that's the thing to kind of keep in the back of your mind. There's a balance there. People sometimes forget this, by the way. Like if you're dealing with daily time series, this is actually something that can bite you. You only have 365 days in a year. So let's say you've got 5 years or so, like, all right, maybe we've got 1,500 data points, maybe. But that's for a machine learning model, that's not a whole lot of data to go on. And there's also this kind of worrisome thing where stuff that happened in the far past, like 5 years ago, might not really make much sense to include in the model today. So just be kind of aware that in the end, you are at risk of throwing away some valuable data. It might not be the biggest problem in the world, but especially when you're dealing with these big lags, you're going to eat up a whole bunch of this data as well. So it's just something to keep in mind. But okay, that said, this is just pre-processing, right? So no model's been made just yet. But this is useful for debugging reasons. In reality, you're probably not going to be using this directly as much. What you're probably going to do a bit more is you're going to so let's just run that one for good measure. This is pretty fast. Again, the datasets are not super huge or anything, but I'm training my histogram boosted regressor. I'm also training my linear regression model. All of these features are the things that are going in. And the thing that I can then do, and I thought that was actually kind of cute, is I can then say, look, give me the forecasted prediction. So take the final date per group that I had, and predict, in this case, 7 times 8, like 8 weeks ahead. That's basically what I'm asking it to do here. And it goes ahead and does it for you. So that is definitely kind of nice. Like notice, by the way, that every model we give it, it's actually being passed in here. But yeah, I've got my predictions data set at the ready over here. And one thing that you can also do is there's these utilities inside of this tool that allow you to do some quick plotting. And I am going to zoom in on this one quite a bit. I have to zoom in manually, but let's just zoom in like so. So this is like a time series that is being predicted in a plot. Here is kind of the boundary. Let's draw that a bit better. So there's a boundary over here. So this is the stuff from the history. And this is the stuff that we're predicting forward. Right. And the main thing to kind of observe here as far as that recursive thing goes is I think I'm only able, like at this point in time, I'm able to look back 2 weeks. But you can definitely see that, you know, predictions forward are being made definitely in a nice way, I would say. So you're definitely able to, these are, yeah, I think these are months, by the way. So you can definitely see, even though I'm only able to look back 2 weeks, I'm definitely able to predict months ahead. So internally, it is reusing predicted values to predict stuff that's happening more forward. You know, so this is the basics. Like there's definitely like details we can talk about. We can talk about evaluations and all of that. But as far as like the basic building blocks of Nixtla goes, the ML forecast library basically gives you this API. There are some extensions as well. Like we can also make an attempt to get like probabilistic values around this. So you can kind of maybe get like a confidence interval. That's something that you could do. But the main thing at this point is, for me at least, is just to check if there are like questions, because this would be a really good time to ask. The main thing I really hope at this point is that the Lego bricks are kind of clear. But if something is unclear on that front, now would be a good time before I move forward. Because I'll be moving I want to showcase this one thing that's related to Optuna, because that's something I promised last week. And after that, I want to sort of try and build a system that actually makes a prediction on an actual data set. And then we're going to see that even though these tools are all like, they seem decent, you still got to do a little bit of manual work yourself if you want to get this thing to work proper. So I'm just going to give it like a minute to see if there's questions. But I think nothing is coming in, which is, by the way, fine. But just wanted to give that a check. Yeah, okay. Don't see any questions come in. Totally fine. The next thing I would like to then maybe talk about is what about hyperparameters? So if you were to have a look at this call to this ML forest object thing, I mean, you could rightly wonder, maybe I want to try different lag values. Like, what if I look back not just 2 weeks, maybe what if I look back months? And you can look at that as definitely kind of like a hyperparameter. Okay, having a nice thing where we can just insert some values is great, but we probably want to fiddle around and try out some stuff. So what can we do in that domain? And for that, there is basically a config abstraction that if you were here last week when we talked about Optuna, it is the way that basically all this is happening is just with this trial object that I mentioned last week as well. This is just straight from the Nixtla docs, by the way, so this is not the most fancy example. But what you would do now is you would have this AutoML forecast object instead. By giving it this AutoML, by calling this object instead, it is going to do hyperparameter search on your behalf internally. And what you can then do is you can have this function that's going to generate these configurations for Optuna, basically. So as we saw last week, there is a trial, and you can say, hey, trial, there is a categorical suggestion. So we're either going to be looking back 7 days, or we're going to be looking back 14, so to say. So far so good. You can say, hey, there are these categoricals. That's the thing I'm going to be looping over. You can also then say, look, there's a dictionary over here. Some of these lag values, they won't be tuned, but you can also have like these lag transforms, and those lag transforms, they will depend on this categorical lag that we're asking for here. So it is really just Optuna under the hood. That's the main thing to just kind of appreciate. And like another thing that's just kind of different, like you pass in this function into the AutoML forecast object. So far so good. But the other thing that's going to be different if you're using the AutoML forecasting tool is the fit itself. Instead of just giving it a series object, you also got to give it some hyperparameters that will determine the cross-validation, so to say. So you can say, hey, how many windows am I going to do? Like, you're going to do like a rolling window to sort of make your cross-validation splits. You can say about like, I want to predict 5 days ahead. You can set like a minimum number of samples to include. And basically, you can totally expand this. But the main thing that I hope is clear is if you want to do some sort of hyperparameter tuning, you can totally do that. But the way you go about that is you use an AutoML forecast object, and you're going to be logging your stats with Optuna instead. That's the main thing that's going to be just slightly different. I didn't really give this a super serious spin, but it has some support for hyperparameter tuning, so that's good. Like if this was missing, that would be a weak spot, but there's definitely some stuff in here. And I also think it's pretty reasonable to play around with these lags. Like that's typically a thing you would definitely optimize over. So I ran this beforehand. You can see lots and lots of trials that are being run. It reports on a few numbers. But the main thing in the end is you can grab that AutoML object thing. There's this results underscore object in it. You can grab the auto ridge model. You can ask for the best parameters, and lo and behold, it turns out that the best lag value is at 7. So okay, that's something you can see here. One thing that's pretty interesting too, by the way, is I should actually mention that a bit more explicitly. Instead of passing a ridge model in here, I am passing an auto ridge model, by the way. And that is a specific kind of object. It basically wraps around the ridge model, but it just will try to optimize its own hyperparameters for you as well. In particular, there is this alpha parameter in there, if I'm not mistaken. I think that's also what it's reporting on here. That is the regularization coefficient. So don't worry, you can also optimize the parameters of the machine learning model as well in this loop. So didn't want to spend too much time on this. Like, I want to report that there's features for it, but I didn't think this was the most interesting thing to do going forward, because I actually want to maybe try this on an actual data set. That's usually also how I learn, by the way. Like, you can look at the docs and copy the API and confirm that it works, but you usually only learn a tool by just giving it a proper data set and see if you can solve a problem with it. That's where I did learn some interesting things. So I'm going to be doing that now. There is a question being asked: is there any sort of weights to more recent values on the API that you saw? Are you talking about the decay fund? So there's a question from Felicio. Um, are you talking about this sort of exponential smoothing thing where, hey, I want to predict YT, and I'm going to weigh stuff that's in the past way less than stuff that's been happening recently? Like that, is that the thing that you're interested in? If so, I'm going to show you a trick that kind of does that. I didn't see it straight up in their API though. But the trick that you can do here is you can basically apply a decay operation on your scikit-learn model using a little library called scikit-learn that I maintain. But you can basically get this behavior on the scikit-learn level as well. So yeah, the docs for Nixtla were pretty big, so I don't want to suggest that I know for sure that this is not a feature of Nixtla. It's just that I didn't immediately see it. The way I went about experimenting with it was straight up in scikit-learn though. Nixtla has a pretty big documentation page, so it could be that I missed over something. But yeah, let's talk about a different data set now. So if you are on our Discord, you can talk to me, and in this particular case, Ivan, who's been a frequent fan of the show, he basically suggested, like, hey Vincent, I've got this data set of the Seoul subway stats, and this was kind of interesting. So you can imagine Seoul, big city in South Korea. And inside of that city, there are many different subway stations. And the interesting thing is, I'm going to pretend to do some sort of like, if I work there, what might be an interesting time series task. Like, one thing you might want to know is just, hey, I've got this one station. How many people leave the station? If I can kind of get a good guesstimate for that, maybe that will help me do some planning. So things like, hey, a subway station has gone bust. How many buses do we need? For that, we need to know how many people will sort of leave the station, stuff like that. And also, like, it'd be nice if we can see, is there a growing trend, and can we model that? And this is stuff that you can probably do with this data set. So the way that this data set works is there are lots of subway stations, and they each have kind of their own little code. So this subway station has about, I think this data set has 10 subway stations. Well, more than 10 actually. I'm just grabbing a subset, but there's lots of these codes, so to say. And there is a division, like there's getting into the station, there's getting off the station. I'll just be looking at the getting off bit. But I've done some like light data preparation here. It might be fun to also just have a quick look at that data frame. Like, this is what the data frame looks like. So after cleaning it up a bit, there are these dates times, and there's a Y value. There is a unique ID, which we will need, and that's the subway station. But for every date time, we've got a Y value, and these are for the hours in the day, by the way. So we're not doing a daily thing. We're doing a date time thing. Like, the hour of the day really matters as far as people getting off. Depending on the task, you could choose to aggregate this, right? Like, you could say maybe for some tasks, I only need to know the daily number. I don't need to know like the per hour number, but I'm going to assume the hour number in this case. I felt that was more interesting as well, because the previous example just did the daily thing. So let's have a quick look then. What I've got over here is basically like a chart of one of these subway stations. And right off the bat, I kind of want to show you a thing I learned about Altair. So I've got my machine learning data frame over here. And I'm definitely like zooming in on like a unique ID, right? So this is a specific subway station. And, I can kind of scroll around, and you can kind of see this daily and weekly pattern, right? So there's about 5 days over here where there's like a pretty big spike. Then there's a day over here that still has a pretty big spike, and then there's a day over here that doesn't have one. So, all right, I'm kind of assuming this is Saturday. I'm kind of assuming this is Sunday. And this is kind of a week. And you can see like the 5 spikes, and then there's a drop that repeats a few times. But then you also see days like this, where I would kind of expect there to be like 2 more spikes over here, but there's none. So it feels like somewhere in February there might be like a holiday where people sort of stay inside instead, or I'm not a local, so I don't know what holiday this might be. You would have to maybe ask like some sort of business person, but you can see that like there's an outlier over here in a way, and there's also one over here. At this point, I don't know if that's like holidays or if that's, there was construction. That can also be a reason. But making this chart definitely makes me kind of appreciate what I'm dealing with. But if the thing with Altair, you can set a interactive property on it, and then what you're able to do is you're able to zoom in. But this kind of zooming is super useful for scatter charts, but it's kind of useless to me when I'm dealing with time series. Like when I zoom on a time series, then I actually want this y-axis to stay the same, and I just want to zoom in and out and move on this x-axis instead. So if you're doing time series, please, if you're going to do anything to make your day, what you can do in that interactive call inside of Altair is you can set bind y to false. By doing this, you're basically telling Altair never zoom in on the y-axis. If I then were to make the same chart, but zoomed out, I can sort of scroll from left to right, but I cannot sort of scroll up and down anymore. But I can also choose the zoom, and the zooming will only happen on the x-axis. If you're going to be debugging a time series and you want that to be super interactive, oh by golly, this is the bee's knees. Like that bind y equals false. Ah, good grief, that's a savior. Because otherwise you're going to be remaking these charts over and over and over again. But having an interactive thing flagged on, like, today I learned. That was a definitely cool thing to learn, actually. So with that little commercial out of the way, like the main thing that I hope is clear is we are dealing with a somewhat regular time series. Like we do see that there is like a slight uplift, right, over the long term. This is like 3 years. So it definitely feels safe to say that there are more people visiting the subway. But if I were to just make a like gut check, it definitely feels like this is mainly a seasonal thing that we got to estimate. It's a very strong seasonal pattern. Maybe there's like a slight uplift over here, and probably there's like a few holidays that we got to mind ourselves with. But just for the base task, let's do seasonal stuff, and let's see how far we can get with just that. We do the ML forecast thing. And in this case, I just figured, let's just do the simple thing. I'm just going to do ridge. I'm going to do histogram, gradient boosting. I'm going to throw in a few lags. I'm going to set it to hour. There's the hour of the day as well as the day of the week that I'm giving the model. Let's just see how well this model does. Let's make some predictions. So I've got my forecasting object over here. Let's actually can I run that cell? Yep, there we go. Run a few cells, right? So one thing to kind of notice here, by the way, I am taking a very big lag over here. That's because I want to look back 24 hours ago, like what happened yesterday. And I also want to look back what happened a week ago. Like it feels like that might be a relevant thing to also check for. Sometimes that makes sense. Sometimes you're way off. Like if a week ago was a holiday, then it's going to be hard to predict today maybe. But, just want to make sure that we can generate those features. After that, what I can do is I can tell the model to fit the ridge regression, make the predictions. So just like before, all of these unique IDs are subway stops. I'm doing hourly predictions, ridge model, gradient boosted regressor. And let's also make that into a plot. And then here's what the results kind of look like. Just out of the bat, same chart as before, basically. I've got some historical data and we're making predictions over here. If I'm not mistaken, the light blue line, that's a bit more spiky, that's the histogram boosted regressor. And the line that's just a little bit more modest, that is my ridge regression model, so to say. And if I were to just sort of peek here, I'm actually not that impressed at like the current setup. Because if I look at the peaks over here that come around every single day, you can totally see that both models are just really not getting it. It's total swing and a miss, basically. Another thing that's interesting to see is that the boosted model is definitely more spiky than the ridge model. But as is, I'm not doing something right. I'm probably missing some features, mainly because I can see that it's missing some stuff over here. This is also, by the way, a way I like to model. I like to start with something simple, and then I like to look at the results, and then I like to sort of reflect and sort of think like, what's the main thing that's bothering me at the moment? And the main thing that's bothering me right now is the fact that this model is not grabbing these high spikes that I need. So that's not Nixtla's fault, by the way. It's probably because I didn't give it the features that it needs. But that's a good first step. Like, okay, we tried the very first model. The loop is kind of done now, but we can now start thinking about ways to fix this. So I figured, what's the simplest thing that I can do to maybe fix that? And the simplest thing that I could kind of come up with, which is something that maybe I should have started with, is what I can just go ahead and do is I can just say, look, let's grab one subway, and let's group by the day of the week as well as the hour of the day, and let's just calculate the median. Because if I just do that, I kind of get this pattern, right? And this actually looks like the pattern that I'm typically interested in. Like, oh, the average, yeah, not bad, actually. That's, maybe we should do something with this, right? Like, this was like a very simple model. Maybe we don't even need ridge. Maybe we don't even need gradient boosting. How about we just benchmark against taking the median for the hour and the day of the week? Like, maybe that's actually the super simple model. And probably if I just do this, then the spikes should at least be there, right? Like, that feels kind of like a reasonable thing. So I did a few mergers, but the cheeky thing that I then did, and this is actually kind of a nice feature of Nixtla, by the way. Like, I figured I might as well make a custom scikit-learn model for this. So from scikit-learn base, I'm grabbing my base estimator, I'm grabbing a regressor mix-in. This is a model with no hyperparameters whatsoever. But what this model will do is it's going to take a look at this data set that's going in. In scikit-learn land, you expect a y parameter. So I know that this is a data frame, but the data frame is going to have y attached to it just for now. Because that way I can very easily just do the group by and then calculate, in this case I'm calculating the mean. I should change that to median in a bit maybe. But just calculate the mean, grab the y variable. This is now something that's been fitted. And given this aggregate data set, I can now, at prediction time, do this join basically on the day of the week and the hour, fill in missing values with a 0, and then also report that y back. This is basically a model that's doing the group by thing, basically. So I thought that was just kind of reasonable. I'm really not doing anything fancy here, but I did think, like, okay, let's do this grouper model thing. Like, let's see how that performs. I can also give that to Nixtla. It feels like that's a good benchmark. What you can also do, and I thought it was actually kind of rad as well, is I figured, well, what if I didn't want to do this? What if I didn't want to do this task this way? Well, like, what if I wanted to do this with scikit-learn? Can I do like a group by model kind of a thing with scikit-learn? Well, because Nixtla really just accepts a estimator in here, you can give it a custom estimator, but you can also give it a custom pipeline. That's also something that Nixtla totally supports, which is a nice feature. So I can do a similar thing with Scrub. Scrub has a select calls estimator that will allow me to select the hour and the day of the week. Like, I'm only going to be using those two features from the data frame. I can one-hot encode all of that, basically. Something I could totally do. And after that, I can perform ridge. So that's also kind of like a model that just only receives these categoricals for hour and for day of the week. And that's also kind of like what I'm doing above over here. And what I can then also do is compare that to the histogram gradient boosting regressor. Notice that this histogram gradient boosting regressor gets a little bit more data. I'm giving it also the month of the year, and I'm also giving it lag values. But okay, like, will this be better? Was kind of a thing I was wondering. And here's what the new predictions look like. So what I thought was kind of interesting is that when I run it in this mode, and again, like, I can rerun this cell over here. There's different subway stations, so I'm only looking at a few subway stations at a time over here, so I'm definitely cherry picking, right? That's something to remember. But one thing I thought was at least kind of cute is that the idea does kind of work. So I think this is the easiest one to show. I have my orange ridge model over here. I've got my grouped model. The group model is kind of hard to see because it overlaps a lot with the ridge model. But if I really were to zoom in here, I'm not able to zoom in more, but you can definitely see there are some spikes over here, and they kind of coincide with some of the spikes that I see over here. The thing that's really hard about this data set is there are like these fluctuations in it. So it could be that, let's say, like, you can see that predictions here are actually a fair bit higher. And it also kind of makes sense if I think about it, because I'm making predictions in like August, early September. So it could be that that's maybe like the holiday season or something like that, which is why I might be over predicting. But one thing I thought was at least kind of cute is that at least I do seem to be doing a bit better than what my like the histogram gradient boosting is still kind of like spiky, but I am able to customize these models manually, and I thought that was just kind of nice. Like the fact that Nixtla doesn't stop me there, was kind of like a nice feature because it allows me to just put in some really dead simple models to compare against. Uh, and you know, from here you can kind of come up with numbers for it, and you can kind of do like benchmarky stuff. But I do want to mention, like, this is the integration seems sound. Like there's no complaints on my side on the scikit-learn integration. It just seems well done. So all right, you know, I've got a few of these predictions. It definitely feels like the histogram gradient boosted thing is sort of overestimating sometimes. The thing that I will say that's just kind of hard is that you know, suppose this is the entire time series. Suppose I take the mean of this entire time series over here. I mean, like, it could be that a year ago we just had way less traffic in August than we have in this year. How do you deal with that? And you might have to do decay tricks in order to really get that right. But one thing I did want to just briefly show, which I thought was kind of a cute result. So what you can do inside of Nixtla as well is you have this cross-validation thing. Now, the way that works is you are going to have to give it your time series model. You're going to have to say, how big is my time horizon that I want to predict forward, and how many windows am I going to make? And then it's going to sort of do split it up into the different cross-validation sets, and then it's going to report back on a number that you're interested in. So this is my data set with all of my predictions. And this cross-validation data frame, that can go into this evaluation function. And that's going to basically allow you to say, hey, I want to RMSE, root mean squared error. That's the thing I'm interested in reporting on. And then you basically turn your cross-validation metrics into like your cross-validation data set, I should say. That's now turned into a proper metric. And one thing that I just want to report on that I thought was kind of cute about doing this exercise is that if I take my grouper model, if I were to compare that to Ridge or to the histogram gradient boosted regressor, sure, the histogram gradient thing, that's doing better than Ridge, but the grouper model definitely feels like it's outperforming both at the moment. And I think that's actually kind of interesting. The main reason for it is that it does seem like this data set is indeed so seasonal that it's really kind of well approximated with a mean, that technically in this case you can wonder if you even need something like Nixtla. Like, it feels like Nixtla could be perhaps heavyweight for this particular data set, simply because just taking the mean is a pretty good first step. But it's still nice to have something like Nixtla because you can still do this experiment and, you know, you can still compare it against all these fancy machine learning approaches. And you do get all the Lego bricks to sort of muck about. But the main lesson that I do want to maybe emphasize here is that even though you get all these Lego bricks, it can still be a good idea to do your own custom thing and to also still think for yourself as well. Looking at this particular time series over here, like, it is just so seasonal. That's the main thing we're going for. There's like barely a trend, you know, and yeah, like, we're gonna have to deal with the holidays. We're gonna have to add something like features for that and stuff. And sure, fine, all that stuff is good. But this is we should celebrate that this is not necessarily a super hard data set. And with that in mind, you might be able to get away with something simple. You should always feel allowed to sort of explore that yourself. Now, there's a few extra things I also just want to show. I think if I go back to, yes, I think this was the prediction thing that I wanted to show. Yeah, there's like one extra thing I also wanted to briefly highlight. And this is mainly a thing that you're going to have to squint your eyes for. But there's also another reason why I think the grouper model is actually kind of good. And that's because it doesn't make one kind of mistake that the other models currently do. So you will notice if you squint your eyes, this blue line over here, right? This is 0. Like, there's a 0 line over here. And you can see that there are 0 values in my original data set. There's just a few values that are very close to 0, let's say. But you can also, if you squint your eyes, you can kind of see there's a jump over here at all these moments. And that is because in my data set, between, I think, midnight and 5 o'clock in the morning, something like that, there are no people coming out of the station. That is because those rows are missing. Uh, I didn't fill those values in with zeros when I was training this. And that is also partially why, um, especially the gradient boosted model, it's having a bit of trouble what to do with those. And you can kind of see over here that it's mainly the recursive thing that is maybe overfitting on time steps ahead. And in this case, you could argue, okay, Vincent, it's kind of your problem because you should have done it. You should have like padded those values into this data frame before giving it to the model, and that would be fair. But I will argue that one thing I didn't like to see here is these are negative values. And this is a data set in which negative values really don't appear at all. And that's, in my mind, at least, like a cool thing about sort of still being a human in the loop is you can very easily detect that. Like, don't look at Nixtla as a black box that you can just not have to do anything for. The fact that you can still get negative values for data, like that's a concern. Like, you should really, really mind that. So in this particular case, the way to fix this is you should zero pad this, and Nixtla does provide like utilities to help you with this, so it can fill gaps. That's something that it can do. But this is like behavior you should kind of be careful for. Like technically, this is a data like the phenomenon that I'm dealing with here. This is a zero inflated data set, as they call it in industry sometimes. That is to say that there are lots and lots of zeros in this data set, and you kind of need to be mindful and tell the model maybe to deal with that. In this case, you can always do post-processing, right? So you can always say in hindsight, oh, we're just going to ignore the model predictions for those time slots because we just know it's going to be zero. Like that's a tactic you could do. But yeah, zero inflation is definitely like a thing that will mess up some time series models. And I thought that was kind of like an interesting phenomenon that was happening here. So all that stuff is pretty interesting still, I hope. I think Nixtla, it is nice. It's just that you should still be mindful of what you're doing. That's the main sort of conclusion I've got. I like that it gives you like a lot of automation and some Lego bricks that are still scikit-learn compatible. But I would still advise people not to see this as a black box. It kind of always works. And with that in mind, I kind of have a final demo that I kind of want to maybe talk about. I'm going to keep an eye out in case people have questions. But there is this one thing that Nixtla is also doing that is very sort of out there on their website. And the reason I want to sort of talk about it is because it feels like this is also kind of an industry thing. Like Nixtla is not the only group doing this. There seems to be a lot of effort to kind of get foundation models working for time series. And that is also something that you're going to see on their website. Like if you're going to go there, you're going to see that this is heavily advertised. The thinking here is that the folks over at Nixtla have basically downloaded lots and lots of time series. There's also talks on YouTube. I've seen a few. But the thinking is that from as many domains as they could, they downloaded as many data sets as they could. So you can imagine there's some energy industry data sets, some stock value things, some social science data, but all of them are different time series. And basically they just try to build a foundation model of sorts such that you don't necessarily have to train your own model anymore. We can just try to zero shot these time series predictions. And this is a hosted service. If you want to use this, you got to get your API key, right? So I figured, technically I was mostly interested in looking at how Nixtla integrates with the scikit-learn stack. But, since I'm at it, why not give this TimeGPT a try on this data set as well? Just if only to make like a little comparison. And you can go to their website. It gives you like a free API key. So, if you're interested in this, like you can definitely give this a spin yourself. But something interesting that I did see there as well. Yep, there we go. So this is the setup if you want to use like their TimeGPT thing. You got to download this Nixtla client. It's a pip install. You're going to want to have some sort of a key. You can get it from the website. You can instantiate this thing that's called a client. You can give it a key to validate. And what you can then do is just give it a data set that you would like to make some predictions on. So what I'm doing here is I'm giving it this this subset of the original data frame. So for one subway station, I'm going to be making all of these like hourly predictions, let's say. But I'm definitely using this pre-processing fill gaps function just to make sure there's no like gaps in my data set. And I'm I'm also telling it here like, hey, if there is a gap, fill it with a 0. And then I get a data set that kind of looks like this, right? So there's a couple of zeros in here. The rest is all like nicely filled in. But what I can then go ahead and do is I can give it this one time series and see what I get back. So that's what I'm doing over here. I gave it my time series, and these are the predictions going forward. I'm asking it to predict 7 days ahead. And if I were to do that, a few things that I think I like is it does seem like it's predicting the peaks somewhat accurately. I think it's also somehow detected that there's maybe a holiday happening here. I would have to dive deeper into that to confirm if this is accurate. But if I were to maybe zoom out a bit, like what you see on top over here, these are the predictions. What you see below over here, this is sort of the stuff right before making these predictions, right? You know, it's on par for the first day at least, right? Like you can see that there are these spikes around 3,500. And you can see that for the first day, we're kind of doing that. But after that, it seems to be shrinking down for some reason. Maybe because it assumes that that's going to happen because there's a holiday here, maybe. But most interestingly, the one thing that I just really noticed is it has a lot of trouble with the zero inflation stuff as well. So, and again, is like a thing I tried on the TimeGPT thing is not like the thing, right? Your time series might certainly be well fitted here, but like one thing I thought was interesting is I padded these things as zeros, but it's still predicting negative values. So I still need to figure out some sort of a mechanism to tell the to tell the TimeGPT model that it should never be less than 0 what comes out of these subways. And out of the box, it doesn't seem to automatically grab that. So it could very well be the case that TimeGPT will be definitely like a thing that is helpful. If you look on their website, they certainly there seems to be enough interest in it that people are trying this stuff out. But don't assume that it's going to be perfect all of the time. That's the main, like the zero inflated thing is something that I definitely hit. It should never predict less than 0. One trick that the docs, by the way, I should mention that if you go to the Nixtla docs, like one thing that they do tell you to maybe do, if you don't want to get this negative value, one thing that you can do is you can take your like your y variable, like the thing you want to predict, and you can basically say, well, let's take the log of that. That way, there's a stronger like you basically turn your y into the log of y, and then when you get your predictions out, what they basically tell you to do is to maybe turn that like calculate the exponential of the predicted value to get your predicted y out. It's a trick that you can do. So it's not like there's nothing you can do in Nixtla to sort of prevent this. The main point I want to make is that this is, of course, not going to be perfect. That's the main thing. If I were to make a suggestion, though, like you might be wondering, like, okay, like what might this TimeGPT be useful for then? For that, I can actually come up with like a pretty sensible use case already. If I assume that TimeGPT is not necessarily perfect, but it's also not going to be stupid, and there's some evidence for it. It definitely zero shot something right over here. Like one maybe way to sort of think about it is, let's say that you've got I don't know, your dead simple model, the group time thing that I made, right? Like this hour per day. Then you've got the TimeGPT model. Let's now also say we've got some sort of a histogram gradient boosted tree thing that we fine tune that kind of works well as well. But let's say we've now got like 3 models. I mean, it is pretty interesting to see when they disagree. Technically, like the main thing that I like about these GPT models is even if you only have one model, let's say, but you will always have that extra model that works differently than anything you're building yourself locally. And maybe when your model disagrees with that thing, something interesting might be happening, and it might be a good moment to sort of just inspect your data quality. And if that, and to me, I can imagine that TimeGPT could actually already be kind of useful for that. It's just like a second opinion. And especially if you're only trying to predict like 1 day ahead or something, maybe that's where it can actually provide some value. I do want to be fair, by the way. Like, I had a quick look at their. They also wrote a paper on this, and they said like, "Hey, when is TimeGPT competitive?" they compared it against a bunch of approaches, and TimeGPT in general was pretty competitive. It's just that the paper and also the talk mentioned that um, it does seem to be performing best on daily time series, so not like the hourly time series one. The hourly time series it was still in the top three, but the hourly time series eventually were best served by these boosted models instead. That's something they did acknowledge on their paper and stuff. So it's not like they're claiming anything false or anything. I think that's actually kind of nice and accurate. But to me, at least, if you're doing something with hourly data, which is still pretty common, uh, maybe the first use case for TimeGPT isn't to sort of see it as a black box that can do everything for you. Maybe the first use case should be something like, it's like another model. I don't have to train it, but I can look at differences, and that's a data quality thing that I might be able to automate. Like that feels like a nice thing to maybe have a look at, because the time series data sets can also be full of errors. And if this is a thing that's going to help you maybe look at that, like that, that feels definitely kind of nice. There's a good question coming in. So someone is asking, like, how can the histogram gradient boosting regressor output negative values if there are no negative y's? Let's zoom in on that, because I think it's possible. It just depends a bit on the forecast definition. So, okay, there's lag values in here, right? It could very well be the case that the model on the data set that it's seeing, like even ridge regression, I think, let's take ridge regression as an example. But let's say I've got some sort of a system where there's weights, right? And there's a weight for my x1, and there's a weight for my, so let's clean it up a bit. There's a weight for my xk, right? And at some point, there's also going to be some sort of weight, let's call that a, for some sort of lag value, let's say. It could be that for all the data that it's seen so far, right, it could very well be the case that this is negative. Like that could be a coefficient that's just negative. Even if all the predictions that are going out are positive, it might be the case that this weight is negative and that it's compensated for the constant. On all the data that you've seen so far, the fact that, the output of this on your training set can still be positive everywhere, even if there's a coefficient here that's negative. Okay, but then what's going to happen? In production, we're going to do the recursive trick. And then we're suddenly going to be predicting time steps ahead. And if we didn't do the zero padding thing in our training data, then it could very well be the case that, hey, we are looking back on a value. Actually, let's make the argument the other way around. Let's say that this is super positive to the extent that this is negative, right? So this is negative, and this is super positive. But during training, we've never seen a YT value that's 0 before, because those were missing values. Well, then in production, if this ever becomes a 0, right? Okay, so the question is, like, for linear models, yes, but for tree-based models, it shouldn't happen. I mean, for tree-based models, you kind of have the same argument. I mean, at least I would say so. Like, there's still some sort of a tree that says, depending on that lag value, if that is greater or larger than 100, right? You're still going to have a split. It's just not going to be a coefficient, I think. It's still going to cut up your hyperspace. So, like, Robert, could you give me because Robert is asking, like, this shouldn't happen for tree-based models. Could you give a very strong reason why for tree-based models this shouldn't happen? Because again, you got to remember, I think the issue here is not so much the model itself, more the values that we're getting. Like, we might be getting values that we just simply don't expect. There's a difference, I think, here in what you see in the train set and what the recursive thing is doing in like validation time. And we can also take this offline, by the way. That's my current theory, at least, of what's happening here. Okay. I'll be awaiting for the response there. But yeah, okay. We're also like almost over time, so we should definitely mind that. But yeah, this was Nixtla. I think there's stuff to like. I really like how you can still do custom scikit-learn stuff in it. That definitely feels good. It feels a little bit heavy in the sense that, you might need to know a bit about Optuna if you want to do hyperparameters and stuff. So it's definitely like one of these frameworks where you got to invest a little bit of time in. It's not like you spend an hour, then you understand the whole thing. Like, you got to take a bit of time to do it. There's also definitely like so many other scikit-learn-ish frameworks for time series and stuff. So I like definitely don't look at this and think it's the only thing that you can use. But I did play around with it and I found stuff to like. It's not a free lunch, but it does give you like good Lego building like bricks. So that's yeah, that's my short review. That time GPT thing. Um, it's definitely early, but I can imagine for like data quality checks, it can already be kind of useful. Just resist the urge to trust the black box fully is the main thing I will say, at least for now. A decision tree can only output values that it has seen in the past as targets. If all y's are between A and B, the tree out. Oh, wait, that's the argument. Hey, that's actually a fair one. So Robert is saying like, yeah, but don't we have the leaves of a tree usually should only emit but yeah, if I look here, it definitely, yeah, this feels negative. So you're right, Robert. You're right. If a leaf of a tree should always predict something that it has seen, I mean, it can predict an average, actually. It can predict an average of a lot of data points. It doesn't necessarily have to be like a single thing it saw in data, but it needs to be the average value of a set needs to be in your data set in the first place. So yeah, this could be an yeah. So that might be a bug actually. I will try to dive into that. But you're right. Yeah. Robert, feel free to join me on Discord. We'll talk about it there because I gotta stop the stream in a bit. But yeah, I'll let's talk about that on Discord. I understand your concern now because it does feel like it might be doing something on top. Uh, yeah. Okay. So no. So this is I don't have the time to do proper debugging now, but I agree. I might ask folks over at Nixtla about that actually. But yes. I need to stop the stream. Y'all, thanks for joining. I hope you enjoyed this one. Definitely join our Discord and you can help discuss what I should discuss next week. Next week, I'm probably going to stream on a Saturday instead of a Friday. We have a family thing. But yeah, I hope this was useful to folks.